A very good morning or in a way, good afternoon to all the colleagues who are listening to this webinar on drip irrigation for rice. I said good morning and good afternoon because the actual webinar will be webcasted at different times. Now, at Jain Irrigation, we have been working on adapting the drip method of irrigation for rice crop, the so-called ultimate target crop for this wonderful technology of precision irrigation and fertigation. And we went through this process after many R&D trials. We went to the farmers' field, different parts of India and elsewhere, and we could keep on proving this, the adaptability and the usefulness of this technology for growing rice. Now a stage has come, we are actually extending this technology through our efforts and the support from others to the rice growers, first in India and few countries overseas. Today I will be talking to you about the technology per se and its benefits and some of the results of actual field research we have done, so that these research topics are chosen and conducted in the field of different farmers as well as in our research and development farm to identify more benefits and the scientific background, the technological background for those benefits while growing rice with the drip irrigation. The idea is that factors like yield improvement, that is productivity enhancement, and higher water use efficiencies, higher fertilizer use efficiencies would be giving support for the overall technology for other people to adapt it and adopt it. Now, with this idea, in this current webinar, especially targeting to Jain agronomists as well as anyone who is likely to listen to this webinar from outside, including our large number of farmers who have been using this technology and who are waiting to know more about the technology. I'm going to concentrate on again the steps of this overall drip method of irrigation for rice crop, then coming to some of the very specific benefits. Now these benefits are actually going to be emphasized so that anyone who is wanting to extend this technology to more farmers and increase its reach to different parts of India have to know this is not an investment made into drip irrigation system. Along with that, the software part of the technology like irrigation scheduling, fertigation scheduling, etc., when followed through, would give a large number of direct benefits to the farmers and some indirect benefits to the environment. And this is the key. This is the key. And even administrators would like to know, even subsidy administrators, government departments would like to know what this technology is about and what it is actually providing to the farmer in India and elsewhere. Now let us look at, that's why I have turned the title as enhancing productivity. Number one is to rice productivity has to go up. Second, water use efficiency have to go up. When these two goes up, we will get higher water productivity for rice. Now, just to go back into a bit of a background, we have about 43 million hectare of rice crop in India, and the irrigated area comes about 21 million hectare, And among the 43 million hectare, rice is generally grown in two different ways. One is the direct dry seeded rice, that is direct seeded rice, where you seed it dry into the soil bed and then irrigate it. And then the conventional puddled transplanted rice, where you are actually raising a nursery and transplanting 30-35 day old seedlings to the main field. This is the way the rice crop is grown. Now, why this technology is becoming very important for Indian situation? That's the first point I want to clarify. In India, the water scenario is actually not very encouraging. If you look at the graph given at the bottom of this slide, you will see the blue line shows the total available usable water in the hydrologic cycle that we have in India. That's about 11,000, that is 183 or so billion cubic meter, or we can also say kilometer square cube. Now, by 2025, we have only about 1/3 of this fresh water what we had today for irrigation. But 2025 is very soon. And by 2050, all the available water, fresh water, would be utilized by then for irrigation and non-irrigation purposes, which means we will actually have a physical water shortage in India. Water availability for agriculture, we use about 83.3% of the total water is used for agriculture. That will come down to about 71%. What I'm trying to say is that on one hand, we are trying to increase the area under irrigation, but we will not be able to proceed on that line because water itself will become short. That's the difficult situation we are going to face. Now, I will explain to you why we need to increase the area under irrigation from, for example, in rice 21 million to more in the next slide. Now, let us look at the food situation. We have an increasing population, which also means higher food requirement. It would be our country, great country, India, would be most populous by about 2050. It is estimated to have about 1.6 billion people, and food production needs to be doubled from the present. We have to almost double that is 294 to 494 million metric ton to feed all the people. The limited water and land resources are actually declining the productivity of rice, for example, among other crops, rice, because we are talking today about rice. And overpumping of the groundwater is creating a situation of overexploitation, and many of the areas farmers find their groundwater cannot sufficiently support their crops. Now, coming back to the food alone, food production can be increased in different ways. Increasing the area under irrigation is only one of them. Getting more land to cultivate is another easier way. But look at the land situation we have. We have the current now about 2,200 million hectare, and the maximum we can get by 2050 is on 232 million hectare. That is area not cultivated, converted to cultivable area, which means to get 494 million metric ton of food, extension of agriculture into newer non-agriculture areas cannot be a solution because it is very limited. What can then be a solution? The last line in the table, total irrigated crop area, which is something 79 million hectare now, have to be increased to 146. But that is where we have this catch-22 situation. We need to increase area under irrigation because land area is limited. We cannot have more cultivable area anymore. But the area under irrigation can be increased only if we have more water resources. And we already seen in the previous slide, as we go along from 2000 through 2025 to 2050, the water available for irrigation actually decreases from what is available now. See, that's what I call it as a very difficult situation. So what can be done? See, India needs to produce about 140 million tons of rice. Coming back to rice alone in these numbers, 140 million metric ton of rice we need to produce. 2 million tons of additional rice every year we had to add for the next 20 years. But irrigated area of rice should double. But then we don't have water to double the irrigated area. So there is only one way out. Make irrigation more efficient. The current irrigation methods have to change to increase the efficiency of irrigation with the existing water source from the current 30% or 32% to something like 60 or 70%. The moment we make 30 to 32% efficiency of irrigation to 60 to 70%, we would be able to irrigate more area. And this is the reason where, or this is the niche where this technology, which is tested in a number of crops, that's a drip irrigation, drip method of irrigation, will find a slot, an opportunity to get into rice farming also. And this is the thought process which probably was behind our mind when we were actually trying to do the first few pioneer tests of drip irrigated rice production. Now, you may ask me, why drip irrigation? Why not something else? Lessons from several crops show that drip irrigation produces higher yield at the least water consumption. That's the point. Excuse me. Drip irrigation enhances productivity 60 to 100%. This is the experience from other crops. And drip method of irrigation conserves water, reduces the water use to 50 to 70% besides increasing productivity. So water efficiency, water use efficiency increases tremendously. And then I just conclude this part, why we chose studies by Jain Irrigation from 2007 to 2019. This is probably an old slide. Even now, we are continue to do that. We are continue to find new things about new observations from drip irrigated rice. 2007 and current also. In many rice growing areas in India, they have proved that drip irrigation reduces water use by 40 to 55%. At the same time, increasing the productivity of rice by 10 to 22%. So this is what we wanted from the previous few slides. You would have understood. We need a technology which uses lesser water and produces more rice. And that is the ready-made slot for drip method of irrigation in the Indian rice agriculture, or maybe agriculture of other countries, rice agriculture of other countries also. There is no magic in this. Now this slide will explain. This is the fate of applied water in a rice farm, rice field. Some water will move away from the field where you are applying because you are flooding it. The tradition is to flood it by wind drift to the next field or to the drain. Some of the water will be evaporated from the surface. There are two evaporations here. Actually, there are three. One, the transpiration we all know from the crop. Two, the evaporation from the wet soil surface to the air. The third one is evaporation from the water surface to the air. That is how most of the water escapes. Then we have water going down. The yellow arrows pointed downwards. Infiltration happens. That means water move down into the soil profile beyond the reach of the root system of the rice crop. Then some cases, depending upon the soil strata and the parent material and the substrata that is below the rhizosphere area. Sometimes water percolates deeper. It's called deep percolation. This water cannot be recovered unless you pump it back. Then we have the classic runoff. When you are excessively watering a field, the water will drain to the lowest plane of land, which is actually runoff. So there are several ways the applied water in a flooded field get removed from that field, not available to the crop standing in the field. The only thing what the crop requires is transpiration requirement and some part of evaporation from the wet soil surface. It is inevitable, it will happen. So you see that of just for two requirements, we are getting into almost 5 other non-profitable, non-usable, non-recoverable escapes or movements of water from the place it is applied to for the purpose of irrigation. And this is exactly what we are trying to avoid. So very simple, drip irrigation methodology applies water just enough for wetting the soil and supporting the transpiration requirement of the crop. So we call it as evapotranspiration of the crop. We are not providing that excess water for surface evaporation directly from the water surface, for runoff, for deep percolation, and there will be some little bit of infiltration even when we do the wetting of the soil, but not large volumes of infiltration and wind. So for anyone to understand what drip irrigation does, it doesn't do any magic. It avoids all the sink, S-I-N-K, the sinks of water which otherwise get into in a normal flood irrigation method. This point, once everyone understands, they can easily think of drip irrigation as a savior, as a helper for the people to produce more rice. Now, this is one of the trial results. Some of the things which I said theoretically in the previous slide is shown here. In these photographs, you will see none of the field, whether during the early germination time or the later growing time and the grain development time, the field is never flooded. Soil is kept wet. That's exactly what the drip irrigation does. So all the other 5 sinks of water loss has been taken off from the crop soil system. Only crop evaporation, soil surface evaporation and transpiration amount of water is given. And when you do that, you are reducing the water use by about 66%. You are reducing by 66%. In other words, 23.75 million liter is used for a season in the flooding, which you use in the drip. You use only 8 million liter per hectare. You also get an increase in yield. In this case, you can see 21.5% increase in yield happened in the drip system, in the drip irrigated crop. Because you are pumping large volumes of water in the flood irrigated situation versus the drip irrigation situation, you are actually consuming lesser units of electricity or power. That also has been some 52% less power is utilized. So this is what I call, this technology has provided a win-win situation. You wanted to produce rice, you wanted an increase in its yield. Okay, based on varieties, we found that about 10 to 25, few cases of 30% yield increase has happened. But this is something which you have to keep working on and find out which variety suits best. All that. You have to reduce the water consumption, it did. And concomitant with the water consumption reduction, there is a reduction in the power utilization. Overall, the farming becomes more economic, more efficient. Water use efficiency, power use efficiency, and the crop also become more efficient. I'm just generalizing it now. In some crops, we are almost doubling the yield. I'm not talking about rice, doubling the yield. The doubling is possible in cases like banana, in cases like sugarcane, etc., because the crop has got a potential yield which is so far unachievable with whatever technology we used till we started using drip and fertigation. Drip and fertigation unleashed the crop's ability to get yield closer to its potential yield. I'm not saying it happened in rice. We still are working on it actually. It will happen. We can probably produce more rice per unit water. That's the point. Now, anybody interested how this increase in yield happened? The second, the right hand side green table shows that we produce more protective tillers, the tillers of rice plant, which produces more number of panicles, the flowers. Then we increase number of grains formed in each panicle. The number of grains are increased, number of panicles are increased. We also slightly increase the grain weight. So all the three, these are the agronomic factors which cause the yield increase, yield change. You get more panicles, that is flower forming stalks, that's a panicle. Number of grains, more grains per panicle, that means less chaff, that is unfilled grain, less. And more weight, slightly more weight for the grain. All the three contributed to their yield increase. And you saw the water use and so this is the basic. And now I'm going to build up on this basics, so that what are the other things we could obtain over that period of time. And this is the tool which my extension friends have to explain to the growers so that their idea of irrigating rice needs to change. Their attitude to the conventional irrigation have to change. Even it is true with the administrators, departments, research institutions who look at all rice as always standing in water. So because that is actually an additional, we didn't have this problem when we were extending drip irrigation for other crops, horticulture crops. But when we were extending for sugarcane, we faced this problem. When we extended for banana, we faced this problem to some extent, but we could overcome. Now with the rice, that overcoming the mindset is taking time. That's what we have. Now, what happens is that if you look at these three, that is flood irrigated rice and the so-called SRI method of growing rice, which is an improved version of the flooded rice. It is still flooded, but there is an improvement in that. I don't go into much details unless somebody asks me a question on this. Then the drip. So you have about 0.13 kilogram per meter cube water in the flood. That is 130 gram of grain per 1,000 liter water. SRI has some whatever data available in SRI has shown that it's become 470 grams, and drip much beyond that, 550, almost half kilo of rice. Instead of 130 gram, we are getting half kilogram of rice per meter cube of water utilized. That is the beauty of this technology, and that is why people are slowly coming, even administrators, government departments, government agencies, and some progressive farmers are slowly warming up to the idea of growing rice with drip irrigation. There are a few other factors. As I go along, it will come up. Now we have, after this basic studies, we have gone for a multi-location studies in farmers field. Large number of progressive farmers were contacted, and those who agreed to do this, we did drip irrigation systems for them and followed up with the irrigation scheduling, fertigation scheduling, and monitoring their crop to see whether this technology is not a flash in the frying pan. That means once it occurs, you don't know when it occurs next. It has to be occurring every time. That's what a technology, when it is actually a usable shape, this has to happen as it is envisaged. The benefits have to incur. Let us see. We have taken a large number of varieties into different parts of Indian rice growing areas, Andhra Pradesh, Punjab, Maharashtra, Karnataka, Tamil Nadu. That you can see, I'm not going into the deep thing. One of the idea behind this multi-location trial in the farmers field is to see whether there is any varietal difference. Some varieties suitable, some varieties not suitable for or some varieties don't even grow under drip irrigation. That was one of the points. The second point was that we have three major seasons for rice, which is a summer rice, kharif rice, most of them planting in June, harvesting in September. That's the major rice season in India. Then we have a rabi season, which is the rain-off season, which is October planting and then January harvesting. That's then in some places a third crop with irrigation they do, that is the summer crop, which is actually been end of February planting and then harvesting after 90 days or 110 days. So there is the seasonality, there are the different varieties and locations, which are soil type, the evaporation part, all that. So this is a very critical part of the long-term study. This is the result. The grain yield in conventional and drip irrigated system, you can see the conventional in red color and the blue color. In all the cases, wherever these two comparisons could be done in the same field or in the neighbor fields of the same location, because there are a few cases where drip alone is there, you can see that, where we could not get a comparatively on the same place for a comparison of a flooded. That is the reason. Anyway, the idea is that the yield was high. Yield enhancement ranged from 14.7% to 29.9, which is almost 30% across the varieties. That is now, it's a fact now. Yes, it's a published thing now. This is something, if you want to question it, you prove otherwise. You have to do it and then prove that it doesn't happen. That's why. So that's what science is actually as you grow. So yield enhancement, productivity enhancement, or nearing to the potential yield of rice variety is happening when you do the drip irrigation. Now I have taken some bit of analysis in this to come to tell you how the different aspects which I mentioned about the season, the variety, the location, etc., will affect and the types of rice, that is a direct seeded rice versus transplanted rice. It's also coming to this. Now here what I have done, the yield increase under drip irrigation, we have seen it actually, yield is increasing. So now the yield increase is being plotted for one variety, which was the most common variety in their multi-location trial, the MTU 1010. There is a summer farmer, there is a kharif farmer, there are too many, and the rabi farmer. So there are this variety as in different farmers' field have been tried in the summer season, in the kharif season, and in the rabi season. So the seasonal effect, you see all the cases, even though the dimension of the yield increase is different, there is yield increase under drip. So that's the first point to be clear. For the same variety, different seasons and different locations. Now I have plotted again the study into the yield increase under drip irrigation with the rainy season versus summer. In rainy season, what happens is this: even though you start with the drip irrigation a crop, the rain intervenes and it adds to more water, so you don't run the drip irrigation system those days when it is sufficiently raining. Let us say more than 20 millimeter rain falls, we don't run we advise the farmer not to run the drip irrigation system. You don't need it actually. It is common sense. So you have rainy season rainwater plus the drip irrigated water. This is what is irrigating the crop. So you have the rainy season, you have increase in the yield is across varieties. It's not single variety, across varieties. In the kharif season, you are getting, which is the rainy season, you are getting increase in yield. In the summer also, where the crop will be more dependent on and fully dependent on drip irrigation, there you are getting increase in yield. So that point also, that confusion or that type of question which people may ask, what will happen, is also been addressed. Now we have another type. The two, as I mentioned, there are method of plantings in rice. The DSR is the direct seeded rice. The TPR is the nursery and then transplanted rice. Look at that, yield increase percentage under drip irrigation. In this case also, whether it is dry seeded rice or transplanted rice, when you drip irrigate instead of flood irrigate, you are getting a yield increase. So that is the point here is proving. Now, to do all these, you need a irrigation schedule. Drip irrigation is not just the plastic tubes which you are putting, the drip lines on the PVC pipe, etc. in the field. how much water each stage of rice planted in June or planted in October, as the crop grows, the water requirement, the actual water requirement, what we call the ETP, evapotranspiration of the crop, also changes. It tends to increase as a function of the age of the crop, as a function of the change in evaporation, that the pan evaporation, which is actually depend upon many factors, other the sun, the solar radiation, the heat, the temperature, the wind speed, and where you are located. Are you located in a temperate region, or are you located in a hot summer like Hyderabad, Central Indian region? So this, all this will be put together. It comes in the pan evaporation. So we use the pan evaporation data. That's what is main daily evaporation. When you have the June 1st fortnight, that is 15 days, you have 5.53 daily evaporation measured in the pan, open pan. Then your crop water requirement will be 12,000, because in June the crop is very small. Its size, it is total biomass for transpiration is very low. That's the idea here. So it is about 12,000 liters. And as the crop grows, as well as the change of climate, July, August, what will happen? The evaporation becomes less because it becomes more cloudy and you have rain coming in there. So the humidity of the will reduce the evaporation. That's what it is shown actually. So with all this, when you become the crop water requirement become a comprehensive measure, and this has to be followed from location to location. This is where the technical input of somebody who knows about plant crop water relations comes in there. So drip irrigation again is a software part where all this scheduling of the irrigation, scheduling of fertilizer, the next slide it will show will come, and the hardware part, the efficient system. System contains the drippers, the laterals, the PV pipe, the distributory pipes, and then you have the head control, which will filter the water, which will inject fertilizer, which actually pumps the water from the source. So that's the head control. When you have the best system, physical system, with the best scientifically designed and estimated software part, there is irrigation scheduling, you have the best results. Now, fertigation schedule is again just like the evaporation value changes from location to location. Fertilizer also changes. So, for example, I have listed here Andhra Pradesh, Telangana has got 180 nitrogen, 62.5 P, and 75 kg of potassium, phosphorus, and NPK. But if you look at Chhattisgarh, the recommendation 220, 55, 125 varies, because these are recommendations made by government agencies or universities. We have to follow that actually, unless we prove it otherwise by growing rice there and then testing for fertilizer, which we have not done. We don't have to do it also. With the existing fertilizer recommendations, I only converted them into fertigation schedule, for which the same ratio is applied based on the growth stages of rice. We will have the ratio as a 1:0 NK ratio. And in the initial studies, we did not want to burden the farmer with the high value water soluble fertilizer. It's a fact. So the phosphate totally is applied as a basal, which will be one of the non-water soluble form, either single superphosphate or diammonium phosphate with a part of nitrogen in it. We applied that actually. That is why P doesn't come in these ratios of the different. So the actual fertigation in this case, but later, as of now, I'm fertigating for nitrogen, phosphorus, and potassium. For phosphorus, I use water soluble fertilizers like the monoammonium phosphate or potassium nitrate. Or the 19, that is complexes of fertilizer. I wrongly mentioned potassium nitrate, which is for potassium and nitrogen. So the ratios will remain same, because these ratios represent the time when a particular mineral, either nitrogen or potassium, is required more in the crop system, in the root system, so that the plant can take it up. That is what the basis of the ratio. So one should know, as the rice grows, what are the different stages of its growth, and then each stage, what are the different nutrients and how much of these nutrients are to be taken from the soil. So based on that, we can apply. So the fertigation schedule ratios are given. For each of these, we provide the farmer with a complete fertigation schedule of each fertilizer, how much in each time he has to apply. But for the presentation sake of encompassing so much variation between Andhra Pradesh, Chhattisgarh, Maharashtra, Punjab, and Tamil Nadu with the different fertilizer recommendations, I try to summarize it by the ratios. These ratios will help us in making the actual schedule of the fertilizer. That is the meaning. Now, let us look at the fertilizer and water use efficiencies here. This is another study. This is not from that multi-location trial. This is a properly conducted scientific experiment in the Panagar University, where we have collaborated with a professor there, and a lot of data is collected. So I'm using some of the data to interpret to you, to show you how efficiencies of fertilizer, apart from water we already saw it, fertilizer also improves with the drip irrigation. So we had the different treatments there in that. We had a control, this is the farmer's control. Then we had a transplanted crop with the flooded. Then we had drip irrigation at 50% of the cumulative pan evaporation. That is how it is taken. You need to discrete the steps in when you do field research. That is fine. Then 75% and then 100%. That is the cumulative pan evaporation for the period is taken, and then 100% is replaced. 75% is replaced as drip irrigated water. 50% is replaced. So this will show you. And then two types of frequency of irrigation. 2 days, that is every 2-day irrigation, and every 4-day irrigation. Just to show how this works out. This result has got a lot of implications, but I am now talking only about the fertilizer use efficiency. From that, here we have done with all these different water treatment, irrigation treatments through drip as well as control, we have kept the same fertilizer for all of them. So that to find out whether drip irrigation methodology per se will improve fertilizer efficiency. That is the objective of the study. It's actually a basmati rice study. As you can see, yield increased in the drip irrigated compared to the farmer's controls. And only 2.2 tons, that is 2,200 kg per hectare. But in the transplanted and the scientist controlled flooded, you get about 4 tons. In the drip irrigation, the moment drip irrigation gets in there, you're getting about 5.3, 5.7. And when you do 100% replacement of evaporation through drip irrigation, you get about the highest 5.2. Anyway, 5.8 tons. The total fertilizer applied is the same, as you can see, kilogram per hectare. And the fertilizer use efficiency, if you take the yield and the fertilizer applied, you are getting a higher efficiency in the drip. The drip efficiency of the fertilizer use efficiency in the drip increased from 16 kg grain per kg fertilizer to 22 or 23 kg, which means drip irrigation not only helped in increasing the yield, it also helped in economizing or bringing more efficiency for the same fertilizer quantity applied in the field. It's very, very important. Drip irrigation increased fertilizer use efficiency. That added to the higher yield. Usually what happens when you have any technology which increases the conventional yield to a higher yield, obviously fertilizer has to be applied more to support the higher yield. Okay, now here what it did, it did not ask for that. It made, because we are using fertigation technology, it made the same quantity of fertilizer to work more to give you more yield. You see, same fertilizer quantity, but resulted in higher yield. In other words, the fertilizer use efficiency increased. All the while we were talking about water use efficiency. Now I'm adding, and power use efficiency. Now I'm adding another factor which is experimentally proved in rice, that the fertilizer use efficiency increased by about 7 kg, 16 kg per grain, 16 kg paddy grain per kilogram of fertilizer has improved to 23.2, 7 kg, which is very, very interesting as well as economically useful result. This point has to be settled into the minds of all the listeners that drip irrigation, when properly used with a good scientifically prepared fertigation schedule, will increase the usability or the impact of the amount of fertilizer you are applying to the field by giving you more yield. So fertilizer use efficiency also increased. Now let us look at each fertilizer. That is, you applied nitrogen, you applied phosphorus, and you applied potassium. In each case, what we call the partial factor productivity, we take the total productivity and assign the productivity to nitrogen alone, or phosphorus alone, or potash alone. Okay. When we do that, we can see the improvements in the nitrogen use, in the phosphate use, in the potassium use. That's what we have done here. The same experiment, but the data was actually looked at in a slightly different way. So here we have the control giving you, that is the farmer's control, farmer's method of application of fertilizer and application of water and growing the crop. It will give you only 15 kilogram of rice grain, which is a raw grain, by the way. It's not the harvested grain, per kilogram of nitrogen. This has gone up the moment drip is put on. Whether irrespective of whether you give 50% or 75% of the total evaporation or 100% total replacement, this has gone to 36, 38, 39 kilogram of grain per kilogram of nitrogen. This is a wonderful thing to happen. You are using nitrogen years together, you are dumping urea into the field and irrigating. You would not have in normal course of time looked at how much this nitrogen is actually utilized and how much of this nitrogen is actually producing you more grain. Now that's what we have looked at it. So when you do drip irrigation and fertigation, you are splitting the fertilizer into small quantities, so its efficiency, there itself its efficiency increases. Second, it is water soluble. You are putting the first in the water, so itself the ionization happens, the fertilizer ions reaching the soil and the root system is ready for absorption by the crop. All this happens, and because you are controlling the dilution rate, the amount of fertilizer every day or every 2 days you are applying, you have the control. It is based on a scientifically designed fertigation schedule prepared by an expert. So he knows how you should not kill the crop by giving too much at one time. That's what the point I'm making. Kill the roots, for example. So here you have increased from 15 kg in the farmer's field, 15 kg grain of rice per kg nitrogen to 39, more than double. Let us look at the phosphate. 37 kg grain per kg phosphate has increased to 97. Very high efficiency of produce. And 55 kg grain per kg potash K has increased to 145. So this clearly shows you this type of studies are required more and more. If anybody thinks that this is only one-time study, this is actually one-time study, 2 times repeated, one location study 2 times repeated, and we have we analyze the data in such a way to understand these intricacies. So here this clearly tells you any fertilizer you are applying to the field for a crop, for a rice crop in this case, if you can fertigate it into smaller doses and follow a scientifically prepared fertigation schedule as per the requirement of the crop, the efficiency with which it produces grain, the ultimate product, increases. Don't you think that it is a wonderful technology then? That's exactly what it is. And that is why I went into details and then do all this analysis to make people understand we are not just talking about replacing flood water with drip. There are a lot of hidden benefits are there. I'm working out more and more of these hidden benefits for you to understand. Now, that part is over. Now, so what the conclusion is that it's not only water use efficiency, it increases fertilizer use efficiency, gives more grain per unit nitrogen or phosphorus or potassium you are applying to the ground. The moment you change the irrigation method from flooding to drip, as well as follow a scientifically prepared fertigation schedule. Now, I'm going to talk about how the drip irrigated rice technology is applied in the field. For that, first of all, you should know where to place the drip system, the drip line, the water emitting line. Now, we use actually either 12 mm or 16 mm. In Jain, we have different types of emitters. So we have the Acuras and we have the turbo lines or the XL drippers, the latest, most precision and less clogging type of drippers we have. And based on the soil type, that is what I'm saying, the soil texture, whether it is clayey or loamy or sandy, because these properties of the soil will describe, impact the movement of water in the soil on the surface as well as water percolation into the profile. In a sandy soil, water moves less on either side of the dripper, and also in a clay soil, it spreads more. It's a very basic thing. But this knowledge has to be utilized for deciding the spacing between one lateral to the next. And this has got a major say in the cost of the system. Everybody's talking about drip system is costly, but when drip system is properly planned for the type of soil which the farmer has, then you can optimize the cost. You are not minimizing the cost, you are optimizing the, you don't put unnecessary amount of plastic in the ground where it is not required. So that's exactly what we have done. What we have done is we have either we use a 4 LPH dripper or we use a 2 LPH dripper, 2.1 LPH dripper or whatever. We have to think about the lateral spacing, because the lateral spacing and the dripper spacing in the lateral is the two components which will decide a costly drip system and a less costly drip system. And not only, okay, that is cost is one side, economic side. The other is more appropriate water distribution in the type of soil the farmer has. That's what I look at it. Then it also helps in the economy. I'll be happy. I'll be happy. That's what it is. So you have laterals, can be at 1 meter on single lateral on each bed, as you can see on the second figure. Is already bedded the soil, which is for medium soil, which is and heavy soils will have more clay, medium soil lesser clay, more loam, less sand. But lighter soils will have more sand, very little clay, and lesser silt. That's how the classification goes. So you can have this. So we have now come to a situation where if you have a lighter soil, then there is more sand content in the soil. You have to use 60 centimeter between two laterals. But if you have a heavy soil, which is higher in clay content, then you can even use a 90 centimeter or even 1 meter between laterals. What I'm trying to tell you is that the soil is very interesting actually. The irrigation is never looked at that way. Irrigation system is never looked at that way. A farmer occupying a land, owning a land which is more of medium type or let us say higher clay content, he will pay less for his drip system than a farmer who is incidentally happen to have only a sandy soil. That's the truth actually. Now this is what is available in the nature, the type of soil. We are inculcating into the cost of the system with the knowledge that the water spread from the dripper reaches, how far it reaches. It reaches only 15 centimeter or reaches 35 centimeter. That's what it is. I hope the listeners have understood the relevance of this, especially when we start talking about rice crop. We need uniform wetting of the entire field, even though no water at any time will be standing above the ground and no water at any time will be draining down for deep percolation. But we have to wet the surface because the rice roots on the surface have to get water and minerals from wherever they are. That's the idea. So we will optimize the system by studying the soil type. We do this for other crops also. Now today I'm talking about rice. That's why I'm stressing it again and again. This also applies this knowledge on this information and this impact to the actual cost of the system when the government decides to give you a subsidy or a assistance for the system. Now, this is the package which we have developed over and tested over 12 13 years in India and also a few other countries. Paddy is planted by direct dry seeding or by transplanting from a nursery. In both cases, it is possible. In dry seeding, we will ask the farmer to do the seeding first onto the dry soil and then put the drip lines. The system will be ready, but the drip lines are not laid because if you're using a machine to do the dry seeding, the drip line should not interfere with the machine movement. So then after the planting, put the drip line and irrigate. The first irrigation and the subsequent 3-4 irrigations are very critical because there are no plants, no rice plant standing. So you don't do any irrigation scheduling there. What you do is that you ensure complete wetting of the bed or the lateral to lateral interspace in a flat situation. In a bed situation is easy. You can have bed is an option, is a better option also. It will take care of the drainage when it is heavy rains and all that. And then for fertilizer use efficiency also bed and furrow is a better system than a flat. But if the farmer says that I don't want to make a bed and it's costly for me, then okay, you do it on the flat also with giving a large drainage or slope drainage for his excess water to drain out. That's fine. The point here is the wetting has to be lateral to lateral or edge to edge of the bed. The furrow need not be wetted. So that you have to first ensure the highest possible population of plants in the field to do anything, not only for drip irrigation, for anything. Your productivity depends upon the space, maximum utilization of the soil space or the surface without shading. So you cannot cut up too many plants also. So this is something that is how the general agronomy talks about the spacing of the crops and the crop geometry and plant population, etc. They are important. Here what I'm trying to say is like any amount of space I expose to the ground, to the direct sun, I'm losing water also. It generally happens. I don't want to do that. So by about the crop become 2 months old, there will not be any direct exposure of the ground to the outside. So that again I'm conserving the applied because the water is estimated for based on the crop water requirement, not on the waste. The water you are likely to waste is not part of the estimation at all. If you do that also, then even then we do about 10% actually for take care of that. 90% efficiency we give for drip irrigation systems. There is a 10% we do, but more than 10 if you are actually wasting water, then you are not getting the best benefit out of the drip irrigation system. Okay. Now, if you are so what I said is that if you are dry seeding it, you seed first, then put the drip line and wet it. The first 5 days you do normal wetting, edge to edge, so that all seeds will get moisture and germinate. Because only after the germination and 2 or 3 leaf stage you can start implementing on the irrigation schedule, which is estimated. Then the other method of transplanting, people say that no, we want to continue transplanting, even though dry seeding is a better option. Then we have to allow the farmer what he wants to do. So, but drip irrigation works there also. We do one thing after transplanting. Here, but the bed ready for transplanting has to be first wetted by drip irrigation. Then do the transplanting according to the spacing which you are planning to plant. You are bringing the nursery seedlings and directly planting them into a wet, not a flooded. Please understand, no puddling, no wetting, and no flooding, only wetting. Wet soil bed. You plant it, and the plant spacing can be 15 by 15 centimeter or 20 by 20 centimeter or 20 by 25. It all depends upon the tillering ability of the variety, which you already know if you are working with the variety. So that if it is a high tillering, you use a larger spacing 20-25, or say very low tillering variety, you use 15 by 15. This is again to ensure to have more hills of rice plants and more panicles. This is very, very important. So whether you do DSR, there's a dry seeding, or you do transplanting. In both cases, this spacing is very critical, and it depends upon the tillering ability of the variety you have. This information is already available as the characteristics of different varieties. Before you do drip irrigation and even planting, don't forget these soils at the last land preparation stage would have received the basal dose of whatever fertilizer you want to add, maybe phosphate, and enough 10 to 10 tons per acre or 25 tons per hectare of organic manure. Please understand one thing: the soil is continually cropped. So if you do not replenish the organic carbon in the soil, which comes through the organic manure, the compost, the farmyard manure, the cow dung which you are applying, you will not be able to apply organic manure through the drip system. It is impossible. It's not recommended at all. So you can only apply water soluble chemical fertilizers through this. So the basal dose consists of, that happens at the last stage of your, just before the bed formation or the last plow, you are applying the required or the recommended dose of organic manure along with the phosphate you apply. In this case, where phosphate also you are planning to do fertigation, do not apply only the organic manure. But this is a very critical information. You have to apply organic manure whether you grow rice or sugarcane or chilies. Our soils in India are very low in carbon content, organic carbon content. Organic carbon is very important even for the utilization of nitrogen which you are applying outside, for example. So organic manure application is important. Don't forget. Okay, you have applied, you either it is dry seeded or you do transplanting with the spacing which is mentioned, and then your irrigation. Once the germination occurs, becomes 2 or 3 leaf stage, you go back to your irrigation schedule given by the expert from the company, the agronomist who is supporting you, and then you do irrigation as per irrigation schedule, and the rest of the fertilizer not as per your traditional 1 shot or 2 shot, 1 split or 2 split. In the X number of split, maybe 35 or 45 splits which we recommend to you. That is very important. You need to do only through the drip irrigation system. You don't need to walk into the field to apply fertilizer. Then one of the things which happens is that when you do rice with just drip irrigation, the likelihood of weeds also, because weeds are already there, weed seeds are already there in the field. So when you irrigate with the drip, they will start germinating, especially in the dry seeded one, because you are irrigating after seeding. The seed or rice seed is competing with the weed seed for absorbing water and then germinating. Okay, so you are likely to get weeds, which is a fact which you cannot hide from this. So we have studied and we have experienced this. You apply a pre-emergence weedicide within 24 to 48 hours of planting, and later about 30 days, 25 to 30 or 30 days before, without fail, you apply a post-emergence weedicide. Our agronomist will advise you the timing as well as the dose and the chemical to be applied. I'm not going into the detail, but this is important. One pre-emergence weedicide, that is before rice plants emerge and the weeds will start germinating, you are already killing them. The second one, rice plants have come and they grew 25 to 30 days and some weeds started coming in, then you apply, that's the time you apply the post-emergence weedicide. In some cases, from my experience, I find this post-emergence you may have to repeat once more, or wherever you can do a economics on that, on the cost economics basis, you can do one hand weeding to pull out the persistent weeds from the field. This is very important for dry seeded rice. Even dry seeded rice without drip, this is a problem actually. That is the weed control is important, because over the years what happens when the water is standing and the rice plant has got a particular physiology, it can stand through the water and stand up, weeds cannot. So weeds are automatically suppressed by the standing water. That is probably the only one positive thing you can think about the standing water. But when the moment you don't have water to stand, you have no choice. You have to go for drip. You have to wet it, just to wet it. And there, when you wet it, the likelihood of this weeds raising their head is possible. So you have to control it. That's what it is, science. Now, then you observe for your different types of insects and diseases, which is a normal thing. There's nothing special about drip. In fact, some of our farmers have experienced a lesser incidence of brown hopper, PPH, in rice, in drip irrigated plotted versus thing. But these requires a lot of verification studies by scientists. That's why we cannot make a rule. It happened. There are farmers who vouch for that actually. They say it reduced the incidence of brown plant hopper, for example. Before harvest, you know the duration of the rice. Every variety comes with a tag. It's a 110-day variety, it is 100-day variety, or 125 days variety like that. So you know when you are going to harvest. And also, farmers from their long years of experience, they don't need any of this knowledge. They know by looking at the rice crop when it is ready for, how many days more it will take for harvesting. So 15 days before harvest, you are stopping the wetting. We are stopping the irrigation. Fertigation would have stopped much before that also, as per our schedules. Then you harvest safely. You remove the drip lines, put it on the side of the field, and then use a harvester machine or labor harvest. You can do both. And then when you complete rice harvest, there are different things you can do with the crop. I'll show you some results of this. In North India, for example, they will plant a short crop of peas or watermelon, then they plant a wheat crop, main crop. So all this, the same drip irrigation system, but the schedules being different for different crops, they will come and ask us. They ask us, give us a schedule for wheat also, give us a schedule for watermelon also. We provide. So based on that, you can take a rotation crop so that your drip irrigation system will have a utility around the year. So that's any more clarity or more details you need, you can ask our agronomists whenever they come to see your field, and they will provide you, or even write to me. Now the weed management also, I've given a bit details. The pre-emergence weedicides 2-3 days after transplanting or 2-3 days of the dry sowing. We use this top star, which is actually oxide diargyl, 45 to 50 grams per acre, or you use a sati, which is again these terms like top star and sati, etc. They are the trade names. Obviously, farmers are more familiar with these names than where the chemical content in them. Anyway, their unit also sold, and people who are adopting our drip irrigation system for rice, all this information and your steps of operation, what we call the standard operating procedure SOP, we will provide you in writing so that you would, and also in your language. It's not in English. We have agronomists speaking the local, each state's agronomists will speak the language of that state. They will write and give you that. That is how we try to extend this technology. Then you have the post-emergence we decide, maybe 10 to 15 days, 25 to 30 days. That's sort of window you can apply, which is nominee gold is one and algeric is another, broadleaf weeds. You can see the farmers applying the pre-emergence weedicide in these photos at the bottom. Okay, now what I just mentioned to you is the entire procedure of planting rice. How the land has to be prepared, how the basal dose of fertilizer and organic manure have to be applied. Either go for flat sowing, but you can also for bed and furrow, which is a better option, or in terms of soil management and the water management. And then we decide based on the texture of the soil, what type of drip system, what is the lateral to lateral spacing and emitter to emitter spacing and emission rate, 2 liter or 4 liter per hour. We will provide the system, and then how it is laid out, and how you have to plant the rice, the spacing of the rice plants, both in the transplanted or in the dry seeded, and then when to irrigate, and the schedules of irrigation and fertigation, and then the weedicide operation, and daily or at least once in 3 days, go to the field and inspect the crop for diseases or insects, and we will provide you the control measures of that, because this cannot be generalized. Each place, each location has got a different type of climate, and this insect cohabitation of the insects and diseases are also different. And some varieties, for example, will be resistant, tolerant to the insects, or the resistant or tolerant to the insects or the diseases. So all this, so this depends upon the location, and the local agronomist of Jain's will come and help you on that. So we have harvested the crop, we have put the drip line on the side, then we put the second crop. So you are having a continuous activity, or a third crop, and then the next rice crop. The drip lines which we are normally giving with the standard, what we call the standard drip lines, can be used for something like a 14 crops or 16 crops based on the rotation. That is 7 years, or sometimes 7 to 10 years you can utilize it. Only thing you have to be careful, based on our advice, you have to do the maintenance schedule, which I'm not touching upon because it will take a long time to explain all the process. But farmers will be advised and trained to do the maintenance by our agronomists who are visiting you. And the system on it will probably can give you 14 rice crops, or 7 rice crops with the 7 wheat crop, or 7 wheat crop, or 8 wheat crop with the 8 rice crop, or potato crop, like that. So it will work throughout the year. You don't have any problem. The same system can be adapted for other crops by changing the scheduling only. Only the scheduling of irrigation and fertilizer you are changing. Now I'll be talking about some recent works we have done to find out more benefits coming out of the drip irrigation technology for rice cultivation. We are doing a large project involving something like in the first year about 21, second year now it's about 49 farmers, which is basically 49-acre land in Haryana on the Basmati. And this project is partly funded by Jain and partly funded by a Swiss agency called Vapro Water Productivity. They have been supporting water conserving technologies in many developing countries, including India. Here, this is the irrigation schedule. It is different. The one I showed you is for different other parts of India, but for Kurukshetra, again, because the pan evaporation from June 15, more or less the planting time, and to September first week, more or less the harvesting time is different. So I have calculated again. So you have the irrigation schedule, and mind you, this is the time the rainfall also occurs. So whenever it rains more than, let us say, 20 millimeter or so, we will request the farmer, will train him such that he won't irrigate, so that water will not be wasted on that. I think farmers are better judges for that. They understand it very easily. But there is a schedule to be followed. The schedule is very critical. Now, when we did this for the this is first year's data. There's a lot of things in this case. I have now taken the water consumption measured. We metered it. Few representative fields, both in the drip and the flood field of the same farmer, we metered and measured the water. So you can see the different. The blue lines are the water consumption, seasonal water consumption, total water consumption for one dry season, meter cube per hectare in the flooding field, in the conventional field, and the brown color ones are the drip. You can see that actually there's a lot of difference between the water consumption. That exactly, we already know that water use, water conservation happens, or water use will be reduced by drip irrigation when you compare with flood irrigation. That actually happens, and that's what, again, I'm repeating this to ensure that this information is planted in your heart, not only in your brain, in your heart thoroughly. That is the purpose. What I have done is that I have then compared this water use efficiency of drip or water saving by drip compared to flood with certain other technologies available to farmers. See, percent reduction water use under drip is 51%. Excuse me, 51.2% actually in the Haryana farms, which we have studied. We take the overall average. There is a technology called alternate wetting and drying. This is what is used in SRI, also SRI method of rice cultivation. where the field is irrigated and farmer will not flood the field. It is irrigated a certain prescribed limit, and then the water level is allowed to go down and the field will develop slight cracks. Then he realizes that he's ready for the next irrigation. There are measurement devices using a PVC pipe. 50% of the PVC pipe is buried with the holes on the body, buried inside the soil, and the other 50% is above. So you can have about 15 centimeter below and 15 centimeter above, 30 centimeter, 1 foot PVC pipe. So when the water level goes down, the subsoil water, the water inside the soil also you can see through the tubes. And in a real sense, these tubes will be buried in 3 or 4 places in a hectare, and farmer will make daily or weekly observation, and his next irrigation will depend upon that. This is called alternate wetting and then drying the soil. In this method, we found in Haryana, wherever it is, it will only say about 18%. Was this from the actual data collected by a lot of farmers' data? 18%. So drip has got a far ahead of that. Drip is far ahead of that because it controls during. It doesn't go to the upper wetting and then lower drying. That is very important. Drip will maintain the same soil moisture throughout. That is why it gives you higher yield and all that. But we have seen it. So 18%, and the percentage reduction under in literature of the rice irrigation literature, I scanned through and found the highest recorded is 23.4%. The paper is also cited here below the slide. Anyway, what I'm trying to tell you is that the other usable technology for reducing the water use, like alternate wetting and drying, which are recommended to farmers to use, which we also tried to make farmers feel, where comparisons can be made, will reduce the water use by about 18 to 23%, while drip will give a blanket reduction about 51%. Just for your information. So there is, if you look at the efficiency of water use, there is nothing above that of drip irrigation. That's the point. Now, rice productivity is shown here. This is productivity. It's not the water productivity, the pure productivity. We got in flood in those places. We got about 5 tons in flood and 5.35 in drip per hectare. That is 0.35 tons, 350 kilograms extra rice is produced. That is, if you look at just the 21 farmers, we got about 5% increase. This is probably not, and this may be the way the basmati rice varieties are going to react. We don't know. We have to see, wait and see, more, get more data and to confirm it. I'm not confirming anything from this. It says that, I'm simply saying, the first year in this project, we got average 5% increase in the yield. There was an increase, only 5%. Now, power consumption. We have measured this flood and DSR. Drip, the first one is the flood. You have about, you use about 7,400 rupees per acre. That is the unit per season. While in the drip, you are using only 1,850. The units are 1,850 versus 888. 888 units in the drip and 1,850 units in the flood. That is kilowatt hour, the unit for which you are paying the electricity. If you convert that into the actual power cost, it is 7,400 versus 3,500. So less than half is the cost of power if you use drip irrigation. But I should add a point here. For experimental reason, for understanding more into the drip irrigated rice, we collected this information from the farmers. Please understand that in many of these states, power is subsidized or fully free. So the farmers at the moment are not probably showing much interest when we say to them that power saving is there. But in the long run, as a country, this technology would help India to economize the use of power for agriculture. Now I have also tried to study some of the, because I'm doing this in Haryana, nearby Haryana, any water productivity experiments are conducted by other scientists in the university also. So I got one. This is a paper by Kaur et al. Kaur and few other scientists together. It's published in 2010. Now, what they have done, they have a continuous flooding like the farmers. Number of 24 irrigations were given for a rice crop. Then one day after drainage, that is actually we are coming to the AWD's practice actually. That means one day you allow for the water to drain, then you irrigate. In the continuous flooding, there is no drainage. Drainage will happen, but you are not waiting for the drainage for the next irrigation. So continuous flooding, one day after drainage, one irrigation, 2 days after drainage, an irrigation, 4 days after drainage, an irrigation. In other words, in 4 days after drainage, you will have lesser irrigation compared to the continuous. So actually you can see 24 irrigations to 14 irrigations, you bring it down. And I have given the water requirement in centimeters in this case. That's what the author has given. And then I converted into volume for you to understand. You are using 19,000 for the continuous flooding per hectare every time you are irrigating, and you are using only 11,000 for this. Yield has gone from 5.51 to reduced to 5.11. Okay, that's okay. Water saving from meter cube per hectare is in the 4 days after drainage, you are using only 14 irrigation. So your total water use has come down by 7,700 compared to the 1 day after, it's 4,500. Okay. The important point I want to do is the yellow colored one. What is the water use efficiency or irrigation water use efficiency? How many kilograms of rice you are producing per meter cube in this study? And she has reported in the continuous thing you are producing only 0.29 kilogram, which is 290 grams of rice per meter cube. Meter cube is 1,000 liter water. While in the 4 days drainage, you are producing 450. In the 2 days drainage, you are producing 4 and 4. Please remember the one of my first slides where I have shown drip irrigation. Our first trial itself we found 550. It is 0.55, not 0.45 or 44. So drip irrigation, when you compare with these methods of water conserving irrigation methodologies, is still superior in terms of both the yield part as well as the water use part. So this study in Haryana and this particular paper where scientifically it is looked at helps for me to reinforce the point I was making all the time. Among the technologies for irrigation available so far, drip irrigation is the most superior, most water conserving technology, which also gives higher water productivity by increasing in yield and reducing the water use. Both, it also is the best for crop protection. That's the point. I looked at the water productivity in our trial, that is the Haryana 21 farmers. You can see here the water productivity, which our measured water volumes in the flood and the drip. Then the harvested yield we collected from the farmers for those fields. We found that in the flood, your water productivity is something close to 0.3. That is between 0.1. Most of the blue dots are there. But in the drip irrigated, you are getting something above 0.6, and most of them are centering around 0.7. That is 700. So drip irrigation once again proved, when you have large data sets like this is 21 farmers only, but you can have still larger. When you get this, you know that it is beyond restricted experiments. It's actually happening in the farms where this technology has to be extended to or adopted. Where such cases, when you get this type of data saying water productivity is very high, then you are actually telling the actual field situation, and people have to accept it. That's why, because this is not a restricted experiment. The experiment also I have shown you. Actually, this is a better one than the experimental results, because experimental results will have several limitations. Main limitation is the area under harvest. So we produce rice in Haryana, basmati farmers, with far less water consumption. Yield increased in marginally, about 5%, but water productivity almost doubled. Water productivity of irrigation, water productivity of rice. That is what I wanted to tell you. When the water productivity increases, what it means is that the irrigation efficiency increased. That's our original theme of this lecture when I started showing the Indian water situation, available water versus required water, the difficulty we have. We have to increase the water use efficiency so that the existing water volume would be enough to irrigate double the land. If we can do 72, now we are doing 72 million hectare irrigated land with certain volume of water. If that I can increase to 150 million hectare, for example, with the same water, then the efficiency of irrigation water is actually doubling. Or existing water will help you to irrigate double the land area. That is what the real requirement of Indian irrigated agriculture as of now. This I'm going to show you some other work also we are trying to do. We are not sitting idle in the sense that, okay, we did this, rice drip works, drip increases yield, drip reduces water, drip reduces fertilizer use, increases fertilizer use efficiency, or decreases fertilizer input, or power, etc., etc., etc. It's all true now. It's been probably amply proved, both the experimental situation and farmers' field situation. But we are actually trying to do more and more. We work with universities like Tamil Nadu Agricultural University, Pannagar, Punjab Agricultural University, Bangalore, US Bangalore, institutions like Regional Research Station of Rice Research Institute in Hyderabad. Then we are also working international institute like IMI and IRI. IRI right now, the photograph what you see is actually the IRI fields. One, the old trial we had in Modipuram when they were working there, and the right hand side of the board is actually the subsurface drip irrigation. We tried that also. Anyway, I didn't specify that. Surface or subsurface, it doesn't matter to us. Rice grows, rice yields more, uses less water, less power, less fertilizer, or higher water use efficiency, higher fertilizer use efficiency. That's what matters. The second one picture is from Varanasi, where irrigation Jain IRI is now currently working, establishing a station there. We are working with them, and different types of irrigation system which we tried with the IRI in Modipuram have shown that the drip uses the water use efficiency the highest. The second histogram, the brown color, compared to DSR flood, transplanted flood, or Chapin system. Chapin is actually drip irrigation. It's a tape system. At that time we are using sprinklers. Now I went back into the rice irrigation research a lot to find out what authorities on irrigation and rice have found out. Now, my main objective was to find out what is the water productivity at different levels. Here I have given water productivity for transpiration water alone. By the way, this trial is not done in a field. It can be done only in a controlled environment like a greenhouse, and with all conditions, so that only transpiration alone you can measure, not the water evaporation, etc., etc. I'm not going to the methodology. When you do that, you are producing, this is done by one of the well-known scientists of irrigation, water use, and the rice, is the Bauman, who is working with the IRI. He is now one of the directors there. This paper 2001 is published. If you use only the transpiration, that is the water going through the rice plant, absorbed through the root, evaporated through the, or transpirated through the leaves. If you use only that water, every 1000 liter water, 1 meter cube, will produce 2 kg rice. 2 kg rice. You see? But that is not possible in a large rice field. We have other sinks for the water, other methods water is being lost. So then we use the evapotranspiration, which is closer to what drip irrigation is. Closer to evapotranspiration, which is basically the transpiration through the leaves of the plant body, as well as the evaporation from the general surface of the soil. They have done that in another study, Swart and Bastnason, in 2004. They got a range from 0.6 kilogram to 1.6, and the mean is 1.1. Let us say when you do put evapotranspiration also evaporation from the general surface also into the water used, you are getting about 1 kg. So transpiration alone is producing 2 kg per meter cube. Evapotranspiration produces 1 kg. But here also, this is in an experimental situation, not in an open field where the farmers use. Now then they looked at the same one of the author with the Bowman, Tong and some colleague scientists looked at the water productivity in a proper irrigated field. They got a range of, because they use different varieties and all that. They got 0.2 kilogram, that is 200 gram to 1.2. But the mean is, which I calculated from the data, is 0.4. That is 400 grams per meter cube. This is the background onto which we build up our data and then look at it. What I'm trying to tell you is that when we did the measurements in the experimental field as well as in the farmer's field, measuring yield and measuring water use, we came to know our latest data says that we can produce up to 0.8 or 0.7, between 0.7 and 8. So there is an improvement. Please understand, in this study, the irrigation which Tong has used is normal flood irrigation. It is not drip irrigation. So in none of these cases it is drip irrigation. The point I'm making is, when you apply a wonderful water conserving and the most available and the superior most technology now available to mankind for water conservation agriculture is drip irrigation. When you do that, your water productivity is always far ahead, far higher than the water productivity measured for irrigated rice so far. That's a conclusion I'm making. Now, we didn't stop at rice. In Haryana, what we have done is we went through the next crop for the crop side for the farmers. And I have given one example here: wheat grain yield, water use, and water productivity under micro irrigation. That's where the products in 2019-20. That is, you see, Rabi crop always starts in 19 and get harvested in 20 because it's an October end planted and harvested in Jan Feb. So that's why. Now it's immediately after 2019 rice crop it is planted. So you have drip yield 4.93 and flood yield 4.84. And we had rain during some rainfall also happened. So that rainfall is also shown here, and the irrigation meter cube per hectare. In the flood it is 2000 and the drip only 617 meter cube per hectare. Variety of the wheat was HD2967. Water use is 2135 and 3537. You have water productivity for wheat is in the drip you have 2 kilogram. Please understand, even in conventional cultivation of wheat is not cultivated and irrigated like rice where standing water is kept. Okay. So you will get for every unit of wheat you are using lesser water applying. You are not, whether crop uses or not, you are applying even in the flood irrigated wheat. That's why you get a 2.31 kilogram per meter cube. The purpose I want to tell you is showing this data is that we produced 11% higher wheat yield under drip compared to the farmers thing, and we used far lesser irrigation than the farmer uses in conventional. So in a rice wheat rotation crop situation, it is win-win for the farmer and win-win for the country because you are using lesser resources. You might have made an investment in the drip irrigation system. That is what I call when the government says we are subsidizing, we are helping the farmer to buy the drip irrigation system. And it is very essential that rice farmers should be provided with subsidy and they should get the benefit like other crop farmers, because they not only grow rice, the rice then go into either potatoes or mustard in the North India or wheat crop. So in both cases, they are using they will be encouraged to use lesser and lesser water, harvest more higher and higher grain, and utilize or consume lesser and lesser power. And when you do for the wheat crop especially, you are pumping lesser and lesser groundwater. That's the point. You are pumping lesser and lesser groundwater if you are growing all your wheat with drip irrigation. Why I stressed on groundwater is over exploitation of groundwater in the North India is a huge problem for the country. So there are these may be small sized solutions, but when you enlarge it, when you scale up, this is what probably going to save this. I would say save this country and save its agriculture, save its irrigated agriculture. We also did the second crop in Andhra Pradesh. Just another example where paddy yield we have got 1.82 tons, conventional is 1.5 tons, 1.5 tons per acre, and we have there's a 670 kilogram extra rice. There is an additional income more than 10,000. The important point here is not that okay they grow rice with the drip. We allowed these farmers, we asked these farmers, don't take out the drip system. You grow your next crop, whatever you want to grow. In this case, this farmer, Bonda Damudu is his name, and this is from the Vaishak district. In 2018, Kharif is the rice, then followed by that he did sweet corn. Sweet corn is a very highly priced, in a way you can call it a vegetable or whatever you can call it. Obviously, maize is a cereal crop, but then sweet corn is actually used for not as a cereal in a way of speaking. It's actually used as a savory. So its use is different. That's what main thing is that it's also. So the point here is whether he grows sweet corn or chili or I'm not it doesn't matter to me at this point from the technology point of view. The technology point of view, after rice, the drip irrigation will support him, the follower crop. That's it. And we have shown and how additional income has come for the sweet corn also with drip irrigation in for an acre, which is 0.4 hectare. He is getting about 19,000 additional income from the sweet corn. So here in these two cases, I have so many of these case studies, but I only want to use one or two to drive the point to you that we should be now talking about drip irrigation system not for a specific crop, especially in an annual crop or a seasonal crop situation. We should be talking about complete cropping system, the rotation, or even intercrop system, the same crop, two crops or more than two crops at the same time, that is intercrop, while rotation is one after the other. Irrigation system, it is proved that will provide more yield, lesser water use, lesser power use, and high water use efficiency, high fertilizer use efficiency, and high water productivity for both crops. So it's an advantage. Now, just like the farmer buys an equipment like a tractor or some other farming equipment, which he can use for multiple crops, multiple years, drip irrigation system, I'm now trying to commoditize it to have the benefits to the farmer accrue to him not once seasonally throughout the year. If he takes 3 crops, it will help 3 crops. Takes 2 crops, it will help 2 crops, and many more years. Now, just for the sake of clarity and in a way of summarizing, I have just put the classical benefit of drip irrigation fertigation for rice. It has enhanced yield up to 50%. Is not for close to the potential yield, not actually for rice, but for across the crop. But for rice, we have seen up to 25. In one, the highest we got is 29.9%. And it produces higher and cleaner straw in rice. Higher water use efficiency already, conserving irrigation water up to 60%. It happens. Then the energy use we saw up to 52%, and the reduce. Okay, there are a few other points which we are not actually quantifying well, and all that. The seed rate used, because we are ensuring with the precision irrigation, we are ensuring 95 to 100% germination of the seed. We are actually reducing the seed rate also. There is another side of the transplanted versus DSR, the seed rate change. That's a big discussion. I'm not going into that. Higher fertilizer use efficiency, and there is When you are applying too much urea, too high quantity in a day or 3 days in the season, you are actually putting too much nitrate, and that will pollute the ground. Here it doesn't happen because smaller quantities, 1 kg or 3 kgs or 4 kgs per acre in a days, in 3 days time or in 2 days time, going through irrigation water, that is how the fertilizer lands it. So you have a lesser chance of pollution, and it maintains the aerobic situation of the soil. Because of aerobic situation is maintained, aerobic means air, direct air interaction with the air from the above the soil also. It will reduce the organic matter degeneration and reduces the methane which is coming up there, prevents methane emission and protects environment. Some data I will show you on this, and reduce humidity, the microclimate, the mosquito situation in flooded paddy fields. And if you live in a hut among the paddy fields, you understand the seriousness about the mosquitoes. Or even if you go and stand in a paddy field, the flooded paddy field all around, in the early evening, you would know the effect of mosquitoes. And mosquitoes also transmit diseases. So there is a microclimate change happening, and which is good for the crop as well as good for the environment, good for you. Now, incidence of disease and insects are lower based on some observations made by the farmers, and no need for land leveling. We know that drip irrigation can climb up and climb down through the tubes. You don't need to level the land, but most of the rice fields are in generally level, but we don't need an additional leveling, which other methods of irrigation requires. Flow irrigation requires, then only water will flow from a higher end to a lower end. You need to do a certain type of leveling. It's not required for drip irrigation. No need for labor use for trimming the bunds, plugging breaches in canals. Totally labor requirement will less, because you need only one person to operate the drip irrigation system and do the fertigation whenever it is to be done, and then go around the field and monitor the crop. Crop rotation is possible. I already said it. Wheat, pulses, vegetables can be rotated. Potato can be rotated. Zero tillage systems can be practiced. We have done it with when we were working with theory. We have seen that actually. We put the drip irrigation subsurface and you practice zero tillage. Your second crop also will grow in that maize or wheat or whatever. So zero tillage practice can be done. It is increasingly coming as a new technology, energy efficient technology for cropping. Soil structure is maintained mainly because you are avoiding puddling, what we call puddling, the grinding of the soil with excess water, which happens every year or every season rice is planted in the traditional method. That will actually make the soil a powder. If you dry that place without any water, then you blow wind, your soil will be escaping not through the water, through the air. So that's the powdering happen. That's so you are avoiding that. You are disallowing that. Even in the transplanted rice, please understand, the drip irrigated transplanted rice does not require puddling. Because one may get confused, DSR, and they understand direct seeded rice. But in our case, even the drip irrigated transplanted crop, when we are asking the farmer to do that, we say don't puddle it. Your bed or your flat land, we will irrigate with the drip line and then allow the transplanting. We have done it successfully. So puddling is totally taken out of the system. So the soil structure is maintained, reduced methane emission. I'll show you some tables, some estimates I have done, and it reduces humidity and lower mosquitoes. The long-term perspective, when large areas in the different states, rice growing states, adopt this technology, you are getting a sustainable resource use in rice production. When I say resource use, irrigation water, power, fertilizer, and soil, you are sustaining. Please understand, soil is a resource. You are not buying. When you buy the land, you get the soil, but you have to sustain it. Many of the farming operations in the conventional agriculture, I'm not blaming them. At that time when they were developing, our knowledge was only that. We never had the new technologies which we use currently were not available some 25 years back. So it's not a complaint actually. But then what happened was that those technologies have to change. People have to change. If there is no change, there is no sustainability possible. You have sustainable technologies, but if nobody uses it, what is the fun? You cannot have a sustainable rice production. This is the point. There are different platforms. Sustainable rice platform is there, but they all have to think hard. Only if you change the method of rice farming from the large number of the farmers currently use to sustainable methods, then only sustainable rice will be produced. That is the challenge. And then finally, the long-term effect is that our first slide showing the mismatch between the food need and the irrigation water and land availability. There was a mismatch. That is where I started. Now I'm matching it. Because when you do sustainably with that efficiency of irrigation increased, efficiency of fertilizer increased, efficiency of soil status increased, then you are getting a food security without harming any of the resources, but by conserving. So we call it as ensuring food security through water and energy, and I can also say fertilizer security. Now this thing I have used, mostly the data I'm going to show you is from what other people have done and published. So it is accepted by the scientific world. At the same time, some estimations based on their results I have done without drip irrigation. Okay, now the first thing is the GHG, the greenhouse gas emission from different crops, which is kilogram of carbon dioxide produced per hectare of the crop. You have 237 kilogram by groundnut crop, pearl millet, chickpea, soybean, maize. By the time you come to wetland rice, see there is a dry upland rice is there, which is not flooded and puddled, which is just because it's upland, it is rain-fed rice. You have 423, but the wetland rice which we produce has got 2,330 kilograms of carbon dioxide emission comes. So you can see and understand from the length of the height of these histograms. Rice is a polluting crop. There are many people have studied. One of the re-study I have taken. They have taken from other scientists' study. In India, in Cuttack, Orissa, some study has been done. The range of methane flux happening is 2.7 to 7.2 milligram per meter square area of the land per hour. The standing crop per hour. That's what we get it. And seasonal total becomes 7 to 19 gram per meter square. Please understand, 1 hectare is 10,000 meters square. And this is some study done. And there are other cases also. There are worse cases in USA. Some studies measured about 22 to 149. This depends upon the study environment, where it is done, what season it is done. A lot of variation in which variety of rice is grown. All that is there. But then let's not compare. The China data is also available. The point and Los Banos, Philippines data is 42 gram to 42 gram per meter square of gas methane emission happened. That is the study from UV. This is just to give you an idea that growing rice with a conventional method actually produces very high volume of methane gas. What I have done here is the just summary benefits from the Agro project. Obviously, the methane emission is not directly measured based on some conversion factors obtained from the thing. And one Swiss gentleman, Dr. Ers, also helped me in actually working out this thing based on the data collected and based on the methods of estimation. Methane emission tons per hectare in 120 days, 3.7 ton in 120 days happens. That is the crop period. In flood, in the drip, it is reduced to, because it is aerobic, reduced to 1.9, and so we got about 49% less emission. And methane, of course, for the people who are working on climatology and climate change and all, they understand that everything has to be converted into carbon dioxide equivalent. When you convert carbon dioxide equivalent of the methane produced, you are producing in the flood, you are producing 92.5 ton. That is the equivalent, 92.5, the carbon dioxide equivalent of 3.7 tons per hectare of in a period of 120 days. You are reducing that by 49%, because it's only a conversion ratio, the percentage remains the same. So estimated savings from the drip totally, if you do the conversion of this is the estimated for a number of cases, it is 60%. Drip can help in reducing that. But I'm very sure if you do actual measurements in different locations and different regions, you can still get a higher percentage reduction, provided you are monitoring the water, your soil, as well as the actual measurement of methane gas, which obviously we are planning to do. We could not complete it for different reasons, especially because in the last 1 year we were all sitting in some offices in front of a computer and working. Let us look at the challenges of this technology. Now, I talked a lot about it, and I'm very sure many of you would have understood what are the benefits, what are the hidden benefits of drip irrigation, which probably you may not have thought of. But there are some challenges. One of the major challenges when we work with other agencies and rice growers is the weed control itself. Many people are still not convinced and not getting the complete control, or let us say manageable control. I call it weed management, it is called. It's not weed eradication, weed manageable. So manageable control of weeds. Pre and post emergence weedicides are to be sprayed. This is the method, but then ensure complete weed control by 40 days of crop. This is what one challenge, which is something which we can overcome, which can do by choosing the correct weedicide and also practicing on the correct timely application. Micronutrient. One of the things is that in this is not only nothing to do with the drip irrigation. The moment the puddled and wetland rice is taken into DSR, the transplanted, instead of transplanting, you go for the direct seeded rice. There is no water is standing. Even in the SRI method, they found out that zinc and iron deficiency symptoms occur. In other words, they aggravate the zinc and iron deficiency can occur in rice fields, all types of rice fields. But this in the direct seeded one, when there is no flooding and etc., for some reason, these are aggravated. So that has to be overcome by our knowledge, as well as soil testing before planting and application of zinc and iron, either in the chelated forms. We can later spray also. So that's another challenge, which but it has a solution, like the weed control. The most important and the most difficult one is the mindset. Why drip irrigation? Many people ask. I'm not familiar with the growing rice with the drip irrigation. Not only farmers in the thing, they probably at least give us 40 plants and say, let me try for some small area. Even educated people or the people who are not farmers but may affect the decision making process, even they are not fully convinced. So that is what we have to build upon this. We have to complete this. Even this webinar is for that type of build up, to understand the strength of this technology. Farmers long held believe that rice grows only in standing water. That is the mindset. So that mindset slowly, I'm very sure it will be done eventually, because we have no other future. Our water future, our irrigated agriculture future is very grim. And interestingly, some of this is I picked up from a paper. Therefore, one author has written, when you calculate water requirement for rice, he's justifying that. Therefore, when calculating how much water is necessary, one must take into account more than simply the quantity which the crop physiologically requires. That's what the UTP we are applying, the amount of evapotranspiration. One must also factor in how much water percolates vertically into the soil to recharge the groundwater, and how much trickles back into the drainage channels and paddies downstream through lateral percolation. Now, in other words, this probably says that the water source, when you do long-term planning and large-scale planning of irrigation water allocation for farming for rice, you have to take into. This is precisely what I was saying in the first slide with so many yellow arrows, and also what are the ways where water is being. One of the argument with many people says that water which is percolating deep will eventually join the groundwater and then it will not be lost. I agree, physically I agree. But my question is that power is used to bring that water first of all from a deep bore well to the rice field and then allowing the water to go back to the groundwater? Aren't we doing the right economics or the right conservation, or we are just becoming a prey, PREY, a prey to the natural order? And I don't think science will allow us to become just a standby, standby and then look at the losses. Anyway, in that paper, he says that water resource and rice paddy cultivation in Asian monsoon region. There's nothing wrong in what he said. He's only saying that when you are planning for this, you have to take into consideration water, otherwise get lost from the system when irrigating rice. Very simple. So according to him, the raw rice production will require 4,700 meters cube of water for 1 ton, or 21 gram of rice per meter cube. Same old story of the water productivity. We are not made any increment. Now these things have to be, we have to probably get more people adopting, more people understanding the technology, and slowly overcome these difficulties, and also make sure the mindset of not only the farmers, including some scientists, the mindset have to change. Otherwise, we will have food insecurity as a persistent problem. Thank you.
Water is life. We all need clean water to live, to grow crops, to thrive. But there just isn't enough water or land to feed our hungry world. Unless we change the way we grow food. That's why millions of farmers are turning to Jain. Jain is totally integrated, totally innovative. Farmers helping farmers. The company logo reflects our holistic cycle of shared values. The sun, source of free renewable energy. Enhanced crops thanks to tissue culture plants and improved inputs. Water used sparingly and intelligently. The land protected and used wisely to deliver more. Jain has become a worldwide force in irrigation technology, the agri-value chain, and green energy solutions. Headquartered in Jalgaon, India, in just 2 generations, the company that started with 7,000 rupees has become a billion-dollar organization, the world leader in agrotechnology. Jain starts with detailed 3D designs and provides the widest range of irrigation products and solutions. In this remote part of the world where there is no electricity, Jain's solar-powered pumps provide on-demand irrigation through a variety of Jain pipes to irrigate the roots of plants produced in Jain's own fields and greenhouses. We pioneered the use of drip tapes for row crops with the innovative Chapin tape. Thanks to our Micro Irrigation Systems and close work with farmers, we help them grow better produce that sells for more. We have even created a breakthrough technique to grow rice with drip irrigation. The result, better yields and better quality. Israel is known for bringing advanced irrigation to the world, and Nandan Jain led the way with integral drip line and sprinklers. Jain, total integration, total technological innovation, whether you farm 1 or 100,000 acres. No one offers a greater variety of products than Jain. On 5 continents, Jain is transforming the lives of farmers. Millions of farmers, 10,500 associates, more than 1,000 agro specialists, 30 production plants, sales in 116 countries, 7,000 dealers and distributors, global leaders in micro irrigation, mangrove processing, tissue culture plantlets, pioneers in solar agri-pumping, producing 40,000 kilometers of drip tube every day, with annual revenues exceeding $1 billion and revenue growth of 1,400% in just 10 years. Why is Jain different? We are a global company that built our business on results, trust, constant innovation, and total integration. We are financially strong, enjoying steady, sustainable growth. We believe that you need to leave the world a better place than you found it. We believe in sustainability. We invest heavily in our people, our partners, and critically, our farmers. Food and energy security is tied to water security. But with today's technology, no one should ever go hungry. And every farmer, no matter how small or large, can produce more crop per drop. There is no need to fight wars over water, because if used wisely, we can make it last. Water is life, and at Jain, we are dedicated to improving life everywhere for everyone, now and in the future.